Hey everyone, geophysicist Stefan Burns here. We have had yet another magnitude 6.2 earthquake strike just south of New Zealand. We see the one that struck yesterday, the 25th of July right there. And here is the earthquake that ruptured today, the 26th. It was originally a 6.6 according to the USGS, but within just a few minutes after they posted that earthquake, they downgraded to 6.2. Take some time to crunch the numbers. And so we have a doublet sequence right there, not on the same plate boundary. This one here is the Pacific plate, the Australian plate. This is the Australian plate and the Antarctic plate, but 6.2, same location. 6.3 occurred there on the 7th of July. So we've had 3 magnitude 6 plus earthquakes south of New Zealand. And if we go just a little bit over, we see this most recent 6.6 north of New Zealand, deep, 314 kilometers. Actually kind of a shadow zone where you typically don't get earthquakes. That's kind of unusual. And you'll see with this comment that I've pinned here, everyone should get the earthing shoes. They are awesome. I'm going to talk more about the earthing boots that I sell and the earthing sandals and the shoes later on the video, but that comment came in, wanted to highlight that at the beginning. So we'll talk about that more later in the live stream. And we will also do a question and answer at the end. So if you have a question, then wait till the question and answer part. I'll answer a few questions from the group and then I'll answer all the questions attached to Super Thanks. So you can ask those at any time because it generates a list. I can just go down the list and answer those questions at any time. So yeah, let's get into it. One person is saying that my microphone doesn't sound good, but I am on the correct microphone. So yeah, we will continue. So yeah, we've had quite a lot of these earthquakes along the Ring of Fire. It's actually getting really interesting. And so the question that I have is, when is this next magnitude 8 plus earthquake going to occur? Because we're coming up on the 4-year anniversary. We typically get one per year. We're going to look at a whole bunch of data today, earthquake data. So we're going to look at that record of magnitude 8 earthquakes going back to the year 2000, the turn of the century and millennium, and see their reoccurrence interval. And we're going to talk about zones of highest seismic risk right now. This will not be comprehensive because the Earth is a big place, but just based off of the recent activity up here, the North Pacific with Alaska and Kamchatka, and then going down through Japan, seismic swarm, also then into Indonesia, and then cutting across here to Samoa and the uppermost part of Tonga, and then going down through New Zealand. We've had earthquakes basically along this entire stretch in July. Meanwhile, we haven't had any magnitude 6 plus earthquakes up in this zone on the other side of the Pacific plate. So whether it's kind of it's an unknown whether, okay, since we've had all this slip along there, that would maybe mean that this is the next area that we're going to see slip, or because that's on the other side of the spreading center, often at least it is with down here, right, we have this mid-ocean ridge right there, then perhaps it's, okay, well, we've had a lot of slip up in these zones. Where have we not had any sort of rupture to accommodate the stress like other places have had? And so there are a few spots. Japan is one of them, though this earthquake swarm here collectively has been about a magnitude 6.5, and that's equivalent to a lot of these earthquakes that we've seen, 6.7 Bondasi, this 6.3 right there. But there are some spots that haven't seen any real activity in July. And then also, for example, the Kermadec Trench. You get some big magnitude earthquakes there, magnitude 8. There's a long history of that, even greater. So yeah, there's a lot to discuss. Even places like Hawaii, I've been researching into, turns out they have quite a high seismic risk. And if you have to look at this seismic activity that we've been having, right, Hawaii's been effectively equidistant to all these points. So there's a real risk of magnitude 6 plus earthquakes in Hawaii. Specifically, they cluster around the Big Island. We'll talk about that as well. We'll talk about the space weather a little bit. We have a coronal mass ejection impact, this plasma filament that launched out coming in any time now. We've already seen an increase in the solar wind magnetic field, about a doubling. So a little shock, it seems, already hit us. It looks like there's going to be more on the way. And our solar flare activity has been very low, but there are a lot of sunspots. So interesting dynamics at play right now. I feel like I'm just having to hold my breath all the time with what's happening with the earthquakes. It's almost like a guarantee at this moment in time that we're going to get a magnitude 6 every single day, which this earthquake activity is not outside the realm of normal. But the rhythms and the patterns to it is definitely unique, as is every single fluctuation in global seismicity. But we're hoping on this channel to better understand where the Earth is energetically at any moment in time, aka right now, the present moment, and use all that information, pattern recognition, and more to hopefully have higher probability forecasts, predictions for locations, and just in general to help people know that their seismic risk may be elevated or normal depending on what's happening right now and what happened just recently in the past. And also some of the historic examples, like, okay, we've seen a magnitude 8.5 or a magnitude 9 in this location. That is possible because if you have, let's say, magnitude 9 strike a location once, for example, 2011 here, right? Eventually, it's probably going to happen again. We're talking geologic time. The human time scale is very short compared to Earth's time scale. And so having a magnitude 9.1 there in 2011 and having a magnitude 9 in this region here in 2004, and then having a 9.2 in Alaska 1964, and having a 9.5 in this region there in 1960, right? That's like a pretty fast reoccurrence interval for like the strongest of earthquakes, especially on a geologic scale. That's like literally every single blink of an eye. So yeah, let us get right into it. And we'll start by looking at our most significant earthquakes for the past 30 days, according to the USGS. And so you'll notice this clustering right from the get-go on the western side of the Ring of Fire, which I think is really, really interesting. So we haven't had any really here. This one there is Guatemala. It's not a magnitude 6. It's just a 5.7. So I'm kind of just looking at all the magnitude 6 earthquakes with this analysis here. And this goes back to before July as well. So you also notice this magnitude 6.6 Scotia Sea, but that was back in June 28th. So, I mean, it's within the past 30 days, but really just for July, we've been seeing only high magnitude earthquakes there. This is like a 5.6 or a 5.4 in Myanmar. Again, not a magnitude 5.4. I don't know why they're calling this earthquake here near Reading significant. This was a magnitude 3.6. Like, I don't know why you put that on the map for significant, but sometimes USGS takes these tiny little earthquakes, and because they're in the United States, they make them like, oh my God, it's significant. Or people freaking out about magnitude like 2 earthquakes in New Jersey. It's like it's a magnitude 2, folks. Like, it's not even really worth chatting about, in my opinion. But the magnitude 6s are clustering like this. And so there are a few zones of heightened seismic risk right off the bat. Let's get into them. We have Kamchatka. And this is definitely interesting because if we go back and change this to 30 days, magnitude 2.5 and greater, we see the swarm that's been occurring here. And so we can zoom in on this, set this to show only earthquakes on the map and show the largest. You'll see this 7.4. You'll see these 3 magnitude 6.6 aftershocks, and then 6.1, 6.0, 6.0. That's a lot of earthquakes. Now the 7.4 is by far the strongest, and it's not like these aftershocks are 100% outside the realm of normalcy for aftershocks in terms of their magnitude, but it is right at that boundary of like, well, like, is this maybe just the entire thing of foreshock sequence? Because you sometimes see that where you will get a powerful earthquake like a 7.4, and then within a fairly short time frame, you actually get something even bigger, like a magnitude, let's say 8.5 or even magnitude 9. Like, these are in the realm of possibility. This is a significant subduction zone. So the fact that we've been seeing so much swarming here after that 7.4, and there's been significant magnitude 6 plus aftershocks continuously now. I mean, this occurred on the 20th of July, so just less than a week ago. 6.6, 6.6, 6.6, and then we go here to the 24th of 6.1, and on the 24th of 5.8. So like this very well, it's a probability that this is a foreshock sequence and that in fact it is gearing up to do something like 8.2 or greater or so. That is, or an 8.0 like a megaquake. Anything that magnitude 8 range and greater, that is certainly a possibility for this area. It's already clearly popping off, and the aftershocks are a little unusual. They're not, again, outside the realm of normal is kind of not the right word, but possibility. But it's definitely the distribution of aftershocks there is a little abnormal. Because normally you get something a little bit more like this, where yes, you get some aftershocks. You'll see a whole bunch of magnitude 5s because we had the 7.3 in Alaska. This is on the 16th, and you see the 6.2 aftershock on the 20th. That's more normal, where you get a big earthquake, then you get one big aftershock, maybe two, and then they start to really decrease down in the magnitude. See how we only have a few magnitude 6s here? We have 1, 2, 3, 4, 5, or magnitude 5s. You have 5 magnitude 5s as part of the swarm. The rest are all 4s and lower, right? This is a much more normal distribution for a earthquake swarm after a powerful magnitude 7 plus earthquake. So Kamchatka is definitely unusual right now with its activity, and I would not be surprised if we get something bigger to happen there in the near future. Now, if we look at this from a bigger perspective, we've seen a big release of energy there, big release of energy there, and then we can go down. Let's actually put this back on our significant worldwide, just so we get the big players. And then we get these two down there. So you'll notice this gap in between the two, which is basically Japan, and going from Japan to the Philippines. So this whole area, I would say, now there has been this earthquake swarm there with a whole bunch of magnitude 5s, which collectively add up to something in the low 6 for magnitude, but this whole area there has been hit with continuous energy as a result of these earthquakes, and that is also a zone of heightened seismic risk. We know the historic seismicity of Japan. Also, you get really deep earthquakes sometimes in the Bonin Islands, and so that is one of these places where the Pacific plate, the slab, goes just straight down vertically. And we just had a deep earthquake here, right between Fiji and Samoa, 314 kilometers. And so you get this bimodal distribution in earthquakes. You get them shallow, going from 0 to 70 kilometers down. And then you also get another peak in earthquakes from like 400 to 600 kilometers down. And the minimum in between those two peaks is actually right around 300 kilometers. So this is kind of unusual that it's right in that minimum. It's not like you never get earthquakes there, but to get a magnitude 6.6 right at that zone where you typically have like an earthquake shadow is quite unusual. But here in this location, you do get really deep earthquakes. So this is, one of these deeper quakes, and you get the Pacific plate going down like this. And as a result of that, you actually have at times effectively like the plate hitting a horizontal boundary. So not only do you have the plate boundary here like we see at the surface, but you also have these boundaries down below hundreds of kilometers. And so as the subducting slab reaches that can also buckle and compress and create these really powerful earthquakes. So the fact that we had a big rupture there is, that's like a movement of the Pacific plate and a stress relief dynamic at depth. And one of the other locations where we get that, because you don't have these sort of deep earthquakes everywhere, they're called deep focus earthquakes. One of the other locations you have that is in Japan, in and around Japan. So now, does that mean that because we have one there that this has to necessarily kind of like unlock? No, but it's an interesting idea and definitely one worth considering if we're looking at areas of heightened seismic risk at this moment in time. And then, of course, I mean, just in general, all of Indonesia and like Southeast Asia has heightened seismic risk. But if we're looking at just the Ring of Fire, I would say what we were kind of, and actually I think I need to switch this back now to this guy. What I was watching as well with these earthquakes is that we had this earthquake pop off in the Banda Sea on the 14th. And then we had Alaska on the 16th, and Kamchatka on the 20th. And then we had some earthquakes here, and then we had this one there on the 24th of July. And so I was like, okay, we've had all this move, but we haven't had this part of the Pacific plate move. And so I was looking in and around New Zealand. And actually on my last video, I put out a pinned comment saying like, New Zealand's kind of what I'm watching. And then right after that happened, this earthquake there popped off on the 25th, a magnitude 6.2. Now this isn't on the Pacific plate, but it's right nearby. And then today we get another 6.2. So seems my intuition was onto something there because now we've had this energy move back down below. But in fact, if we are considering all the magnitude 6 earthquakes for July, the first one of July, in fact, was this magnitude 6.3, fairly close to the island or islands of New Zealand itself. So we've actually had 3 magnitude 6 earthquakes in this zone in the past month. And the shadow areas for that, where there hasn't been any rupture, are basically New Zealand itself at the Alpine Fault. You can get big earthquakes there, you can get magnitude 8 earthquakes on the Alpine Fault, and also right here along the Kermadec Trench in Tonga, you get magnitude 8 earthquakes. So I think that's another area of heightened seismic risk. And you can also get some magnitude 8s in this zone. So, I mean, just in general, basically, I guess it's the whole area. But if we're looking specifically kind of at zones where there haven't been recent ruptures, they'd be like right here, be New Zealand itself, then also like this section right there. Because this is a little bit of an area that's quiet seismically, at least according to the recent data. So let's look at the historic seismicity for that zone. I have it right here. And this is set for all earthquakes greater than magnitude 7. And this goes back to 1900, okay? Because we can set this for the oldest earthquakes. I set this for January 1st of 1900. So this is like 125 years of data. And if we go to our largest magnitude earthquakes first, you'll see this 8.2 right there in that zone I just highlighted. So that's an 8.2. Here's another 8.2, and this one's incredibly deep. This is a very interesting earthquake historically. This was in 2018. I believe this is the one where they had a high-resolution seismic station underneath it, so they were able to capture some really interesting data on that. I believe that's the one. There's a few deep focus earthquakes that we've learned a lot from. And it's really these deep earthquakes that teach us about plate tectonics and the movement of plates, because the fact that we get these earthquakes descending down is the primary evidence that we have that there is some sort of geologic feature that is traveling down at depth. And we basically have been trying to figure out exactly the mechanisms of that and creating models to explain that. But that's an 8.2 there. Here's an 8.1, same location. So this zone here is very active in terms of big earthquakes. And if they're shallow, right, one at 600 kilometers is not going to generate a tsunami. But if it's shallow, 25 kilometers, maybe even 10 kilometers, you could get a big tsunami from that. Here, another one. This is right in that zone that we're looking at right now, just a little bit further north of the recent activity and just a little bit south of the 6.3 that occurred on July 7th. That's an 8.1. Here we have another 8.1 up back again near Samoa and Fiji. And then here's an 8.1 there. You notice a big clustering of powerful magnitude 7 plus earthquakes right in this zone, and that hasn't ruptured, but it's been loaded with energy from all around for the month of July. So that's a potential. And then we have an 8.1 here, and this is where we start to stretch out, because to create my bounding box, to get this part of the fault, I also had to include this area there, which is nearby, and we haven't had a rupture there. We've been having earthquakes here going down, but we haven't had really any magnitude 6 earthquakes in this zone for the month of July. So there's definitely heightened seismic risk in and around New Zealand, I would say, based off of current earthquake patterns. And if we go out here, I just want to quickly talk about, before we get to our next zone of heightened seismic risk, which is Hawaii, I just want to talk about magnitude 8 plus earthquakes in general, because we typically get one every single year. Here we have the map going back to the year 2000. And so we can set this to oldest first, already is. Okay, great. We see this 8.0 here, Papua New Guinea. And you'll notice that's the year 2000. This is November 16th. And then 8.4, 2001, 2003, 2004, 2004. That's Sumatra, right? That's a big, big, big earthquake. 9.1 is going to be 32 times more energy released than an 8.1, like the Megaquake that occurred right before it. So that was a huge earthquake. But then we go, that was 2004. We see 2005, 2000, or is this 2000? Yeah, 2005, 2006, 2006, 2006, 2007. So you'll notice that typically it's about one per year. If you just load this up in USGS yourself, it's about one megaquake per year. Some people use magnitude 8.5 as a classification for a megaquake. I'm just using magnitude 8 because we haven't seen a magnitude 8 since 2021. So again, you'll notice it's about one per year. Sometimes it's more than one per year. But then you'll see it stops. You have 2015, 2017, 2018, 2019, 2021, that's March 4th, and that was actually near our zone right now. So that has ruptured recently with a magnitude 8.1. That probably reduces the chance of that zone just in the near future rupturing with a big earthquake. Then we see Alaska had an 8.2 in July 29th. We're coming up on the 4-year anniversary of that. And then the last one here was Drake Passage, South Sandwich Islands. This was August 12th of 2021. So it's been 4 years where normally we get one or more a year. So we're definitely overdue for a big quake. And that energy, it's not like it hasn't been building up. It's been building up. The question now is like, are we going to get a flurry of these things perhaps? Like, that's possible too. Let's look at our data from Volcano Discovery. Here we have our global seismic activity levels per year. And so we can see where we are right now here in 2025. And you see this 7.6 there, Cayman Islands, 7.7 Myanmar. This was like this earthquake burst globally that occurred. We were tracking this as it relates to space weather, the coronal holes, the high-speed streams, them being trans-equatorial and large. And well, we had this significant burst of activity across the globe seismically. We're in that again right now. We've been tracking that. Things did die down, but the coronal holes also weren't really trans-equatorial and as geo-effective, you could say. Well, we've been having that again. This is our most recent burst. But let's scroll down to the past 4 years. I'm going to turn myself off, so just watch my mouse cursor, okay? But here we have 2024. You'll notice magnitude 7's in there, but nothing over magnitude 7.4 or 7.5. Here we have 2023. We get some earthquakes getting close to magnitude 8, but we don't get any. Here we have 2022. We see the 7.7, 7.6. See how the earthquakes typically tend to cluster? 2023 is a little, not bizarre, but it's almost like a regular heartbeat of powerful earthquakes for 2023. But usually you get this clustering. Here we see 2021. And this is where we had 3 of the magnitude 8s magnitude 8 plus earthquakes. So that is quite significant. But then if you go back, this is where we start to see we're constantly hitting magnitude 8 earthquakes, basically. There's, here we have one right here, northern Peru. And you also will see just in general these records, a lot of magnitude 7s. Here we have 7.7, 7.8, 7.6. So if you just go through these records, see these rhythms here, where it was very low for nearly like 6 months, and then boom, all of a sudden you're really getting hit with earthquakes, and then that's even like continuing having like a second bump there. Really interesting activity. We go further down, you see some years are quiet seismically, like 2017, but you did get this 7.9 and an 8.1. And then some years are just really popping all the time. So we are normally getting more high magnitude earthquakes than we are right now. So in fact, you can argue that what's happening now is anomalous on the low side of activity. Whereas a lot of people are saying seismic activity is elevated right now and it's bizarre and anomalous. We're tracking the rhythms and patterns on this channel. I'm not necessarily saying anything is like more than it is. I think that we're due for a change on the up. I think seismic activity is accelerating, and eventually we're going to get that magnitude 8 again, and that's going to be quite disruptive. It could even be a magnitude 8.5 or even a magnitude 9. Our next zone of seismic risk for right now, because of how all these earthquakes have been occurring along this zone here, I would say is Hawaii, because Hawaii actually gets some really big earthquakes. And I did not know this until I pulled up the data. I mean, I knew Hawaii got earthquakes, but I thought they kind of tapped out around like magnitude 6. That is not the case. If you go straight to largest magnitude first, this data set is also for January 1st of the year 1900 to now. I could probably go further back, but let's use the good record of data that we have for the past 125 years. Look at this, magnitude 7.7. That's a big earthquake. That's like a really big earthquake. And this is a short geologic time scale, right? Only 125 years. So that probably means that you have a magnitude 8 potential on the big island of Hawaii. And you'll notice that's the only magnitude 7 in this group. So it's mostly magnitude 6s. Here we have 6.9. That's nearly a magnitude 7 though. That was 2018. Nearly the same location. See, right next to each other. This first one, 1975 for that 7.7. So that zone right there looks like it's very, very active. Those are the two strongest earthquakes back to back over the past 125 years. But in general, you see a lot of magnitude 6s. And on top of that, Kilauea has erupted 29 times in a very regular, rhythmic fashion. So if you talk to local Hawaiians, Kilauea and the other volcanoes, of course, go through different phases of activity. Sometimes it's a little bit more regular, sometimes it's not. Usually it's not. Usually it's a bit more sporadic and sudden and violent, then it kind of ends. But these eruptions at Kilauea, 29 of them now, going back to December, I believe, have been so regular and consistent, and they've been getting bigger each time. So that's really indicating to me that there has been increased magma flow and pressure coming up from the hot spot, just slowly ramping up, which means that there's increased pressure on the Pacific plate here from the bottom up. And now how much does that pressure radiate out to the rest of the Ring of Fire? I don't know. These are all very good questions to ask. And they're questions to explore. We don't have the answers to this. You know, a lot of our understanding of plate tectonics is built off of earthquakes, specifically deep earthquakes, and we have different mechanisms for understanding, different ideas rather, of understanding how these earthquakes even rupture, because at certain depths, the geologic materials should be transitioning from brittle to ductile. So you kind of are like, how would they even have a shear rupture in a ductile environment? So there's a lot of good ideas out there. One of them is in regards to olivine undergoing a crystallization shift, which is exothermic and collapses the crystal structure. So you have a bit of an implosion, and that creates a shear moment. And then you also have this water, this ability for water to sweat out of certain water-bearing minerals, and that increases the porosity, and that changes the ductile characteristics to be a bit more brittle at depth. And so there's a whole bunch of ideas, and they're probably all working together in concert. But at the end of the day, they're ideas. We still don't, we can't be 100% confident in these ideas that we have. And in the next 50, 100 years, we're going to come up with a lot of brilliant ideas that, flip some tables over for sure. So is this increased pressure coming up from Hawaii influencing the rest of the Pacific Plate and the Ring of Fire? Maybe, I don't know. But it's interesting that smack dab in the center of the Pacific Plate. I do think that's really interesting. It's basically smack dab because we have the Pacific Plate. Let's actually switch over to Google Earth for this. This will be a little bit easier to see. And I can just set the Earth off to the side. Zoom out maybe just a little bit like this. So we have Hawaii here and the Pacific Plate, right, going just like this. So it's smack dab in the center of the plate. So could we see a focusing of earthquake energy at Hawaii? I think it's very possible. Now, if we zoom over to the other side of the Pacific Plate where we haven't seen any activity in July, we may see some activity maybe North America. Like the Cascadia subduction zone is locked and loaded. Lots of California. North and south is locked and loaded. We did have a magnitude 7 earthquake here just to the west of Petrolia in December of 2024. So that is, this area right here has recently just slipped. And that is, you notice that that's a pretty significant zone right there just based on the bathymetric data. So you can get big earthquakes there. But in terms of like NorCal, the San Andreas Fault, the Hayward Fault, cutting on down through SoCal, and we had recently on the Garlock Fault in 2019 the Ridgecrest earthquake. At least it's close to the Garlock Fault. But this whole zone here is definitely locked and loaded. But California is not as active seismically as many people think. Mexico is a much bigger area to watch. Mexico gets big earthquakes, and they're definitely more frequent. You go down here, and then you get into Central America, South America. This is where we've had the biggest earthquakes in the world. And you also get deep focus earthquakes here too. But it's on the other side of the mid-ocean ridge. So are we only right now, is the Earth only releasing energy on the western side of the Pacific Plate? That's been the case for the past month. We've only been seeing energy release, significant seismic energy release off on the left side of the plate, the west side of the plate. But is that about to bounce over to the right side or the eastern side? That's possible. Patty here is saying that we just reached KP4 conditions. We are in this little bit of a space weather bump. Let's check it out. Thanks for the reminder. Here we have our real-time solar wind. And so we see that we had this high-speed stream impact come in back there around the 22nd, 23rd of July. We had a G1 storm for about 6 hours, another 3-hour bump there, G1 minus. Just shortly afterwards. This is our interplanetary magnetic field. You see how the field strength went up, and then once that high density region passed, all of a sudden our solar wind velocity increased. We were in that high speed stream, solar wind density dropped, and we've had the magnitude 6.6 on the 24th, and then the 6.2 on the 25th, and then the newest 6.2 today on the 26th. But you'll notice that we are starting to go up once more in our interplanetary magnetic field and in our density, while velocity is hovering around 550 or so. Temperature, big drop in temperature, which is kind of interesting. You typically don't see it fluctuate like that. But we're starting to go up. Now we're at 10 nanotesla. So this is 2 times stronger than normal. The normal field strength for the solar wind is 5. And when you get a strengthening of the solar wind, it pushes in closer to Earth's magnetic field. So we also just see this sector boundary crossing right there. And this is kind of right in this zone. It could just be a little blip, but this is right in the zone now of kind of an increase in the solar wind. And we have a solar storm impact coming in. Now we've reached a KP index of 4. Scale rating goes from 0 to 9. So it's not a G1 storm, but we are in active conditions at this moment in time. And another interesting thing to point out is that we haven't had an M-class flare for 2 weeks now. It's been 2 weeks since we've had an M-class flare. So we can zoom out on our space weather timeline viewer and set this up. to see our most recent M-class flare, which is M2.3. We've only been C-class activity since. So we have had some solar flares, but they've been minor. C-class is the middle category. M-class is second highest, and then you get to X-class. Those are the strongest solar flares. So we haven't had any significant solar flares for 2 weeks now. And in fact, if we zoom in, we just kind of like have been dropping in terms of our X-ray flux. So this is definitely a factor. There's a lot of sunspots on the sun, and they are emitting X-rays and charging up the ionosphere more than, let's say, solar minimum, where X-ray flux is like 1,000 times weaker. It's like 0.1% the strength of the X-ray flux that we have now. But we haven't had any big solar flares really charging the ionosphere, creating these radio blackouts and more. And so as it relates to big earthquakes, what we would want to see probably is a lot of solar flares really charging up that ionosphere, and then we're more likely to probably have something happen afterwards. But right now the ionosphere is not super charged. So we've been getting these magnitude 6 earthquakes. Of course, we did have the 7.4 on the 20th and the 7.3 on the 16th. That was shortly after this increase here in terms of M-class flares. But if we're talking about big earthquake, we probably want that low density, high speed stream, and also maybe some solar flares that pepper the earth just before that, charging up that ionosphere, creating a stronger global electric circuit. Because there is some evidence that suggests, and some ideas out there, that you need a circuit closure for a big earthquake, or at least that helps. So when you have a flow of energy and you're able to rapidly strengthen that because you're able to close the circuit. Let's say you make the air above the lithosphere, the crust, the troposphere where we live. Let's say you make that much more conductive all of a sudden. Now you're able to close the circuit and allow the flow of charge carriers in the crust, whereas before there was too much resistance. And that flow of charge carriers can perhaps help assist a fault to rupture. So the ionosphere is a very critical component of the global electric circuit, probably the most critical component, and determines that atmospheric conductivity gradient. Though you can also have local effects due to, for example, like radon, or if you have electromagnetic emissions coming up from the crust, then that can also increase the conductivity of the air. So there's a lot of different factors at play there. And I also just want to look at our GMV product catalog. I don't think we've had an update yet for our 6.2 today. No, so they're a little bit behind on that. But I just want to show you the deep earthquakes, okay? So we had this 315 kilometer deep earthquake. This is Fiji-Samoa. Then we had that one there in the Malacca Sea, 144 kilometers. But we have to scroll back quite a ways before we get to another earthquake that is greater than 314 kilometers right there. So we do see one here, Tonga, May 14th, 243. That's pretty deep. It's not greater than 314. We have to go all the way back to 2024. So it's quite a scroll. And yeah, we're going to have to go back another page. And we will start to see some deep earthquakes. For example, here, Papua New Guinea, that was October 30th, and that's 521 kilometers depth. Then if we go just a little bit further down, October 1st, 587 kilometers depth, right around that limit. The limit of deep earthquakes is about 700 kilometers. There's never really been an earthquake observed below 700 kilometers. So there is a limit where all of a sudden the earth just becomes too ductile to have earthquakes, because you need that ability for it to break brittly like this. So this is the first kind of burst of deep earthquakes that we've had going back to the end of 2024 with the Malacca Sea earthquake 6.3 and the 6.6 Fiji-Samoa quake. So there's a lot happening right now at this moment in time, and we're about to do the question and answer. So if you have a question, please ask that in the chat. I'll take some questions from the general chat before I go into the The question is attached to a super thanks, so you can ask that anytime. I will absolutely answer your question if it's attached to a super thanks. But before that, I want to just remind people about the earthing shoe products I have available on my website, wildfreeorganic.com/store, because we've been having all these earthquakes and there's been a tremendous amount of earth energy release. And there are biophysical effects to this. Now, those are strongest if you're actually near the site of the rupture. For example, you have this big release of charge carriers and these conductivity shifts in the troposphere, and there's a whole bunch of electromagnetic dynamics that occur before, during, and after a significant earthquake, especially if it's a land-based earthquake. And this can change your, it can kind of alter your biophysics at that moment in time and shift you into a stress response. It can even create like fever-like symptoms at times. I've experienced this myself with the 7.8 earthquake that occurred in Turkey, the biggest one that we've had in years. That was February 6th. I was in Egypt at the time, just about 1,400 kilometers away, and I was feeling super feverish the moment that earthquake struck. It was like 3 a.m. in the morning. I'm in a hostel in Aswan getting ready to go to Abu Simbel, and I all of a sudden got sick for no reason. And, I was just like fatigued and felt nauseous and feverish, but that was it, nothing more than that. And then after the earthquakes ruptured, the 7.8 and the 7.5, within a couple hours, I was basically feeling back to normal again. So it's very, very bizarre. So that's my own anecdotal experience on how these sort of powerful earthquakes can affect you if you're nearby. But in general, the earth is releasing a lot of energy at this time. So earthing and grounding to stay in tune with these energies is ideal, because if you are insulated from them, then it's going to that energy is not going to kind of like flow through you as nicely. An analogy, this is not perfect, but an analogy you can think of is kind of like if you were to get hit by a lightning strike, you would ideally want to be grounded and with bare feet so that it could just flow right through you. It's still not ideal to get hit by lightning, but if you were hit by lightning wearing thick rubber-soled shoes while you're standing on asphalt, it's got nowhere to go. It's literally probably just going to go out of your body like this rather than just flowing through you. So your survivability for a lightning strike like that is going to be way less than it would be if you're like out on the lawn and you're barefoot. It'll probably flow through. You probably won't die. Survival rate, though, is like 30%. But it's a similar concept. So these shoes here are great because when you're in a situation where being barefoot's not really possible, right, then you can still be grounded. Like I've been wearing these boots. These are the earthing boots. I was looking for earthing boots for years before eventually I was like, know what, I'm just going to like get my own made. A company reached out to me in Turkey. They're fantastic. I've been there twice to work with them. We took their initial design and using my expertise in grounding and also geophysics, optimize it to be the best earthing boot on the planet. So I wear these while hiking. I wear these while gardening. You can also, they look pretty nice too, so you can wear them out on the town if you want. Though mine are maybe just a little dirty and beat up because I'm outside working with them, like doing hard gardening work or hiking. The latest addition are the earthing sandals. And so this is what they look like new. And they have these elastic straps to hold onto your foot, but then these are leather, so they're soft. And so they're really fantastic. We have this grip added to the bottom to naturally make them a little bit more tactile and grippy right from the start, because this is all leather construction. So the failing of most earthing products is that they use rubber and they only give you one single like grounding plug, and sometimes it's not even copper. They create some plastic polymer with like little silver fragments and say that works, and I'm skeptical of all this. Give me the good stuff. Give me the copper plug. Give me the entire footbed being conductive already because it's leather. Simple design, right? It's basically just a little bit of leather on the top and then thick buffalo leather on the bottom. Hemp stitching, so it's really nice and secure, looks great. And these elastic straps hold onto your foot, so this stays on your foot. You can even, for example, if you just need to like break out into a jog really quick, sometimes you need to do that. You're walking, you need to catch the crosswalk light. You can do that with these. They're not going to fly off your feet. I love these sandals. And if we look at the difference, they start off flat, right? They start off like this, but they will mold to your feet. Here is my pair that I wear daily. They will mold to your arch. They promote natural foot gait and function. So they are really incredible, and they're quite durable. I think they're actually more durable than rubber-soled shoes, because the leather with the grip, it does build out nice traction, but it also doesn't sometimes unnecessarily grip like the concrete or asphalt. Like sometimes you have a rubber shoe, you like catch it and it like rips a chunk off. Like you can feel it. This doesn't happen. So they're really, really excellent, especially during the summer or just any time. If you live in nice tropical conditions perhaps, and these are the best. And then the other thing that we have, these are the men's earthing shoe. There's also the women's earthing shoe. You can see them right here. These are fantastic. But if you want something that's more of a classic shoe, then we have that too. But again, the soles have the pattern on the bottom, the copper plugs at the K1 meridian point. These are the original model. So they don't have the hemp stitching, nor do they have the pattern on the bottom or anything. This is because this is my testing pair, and I'm not just going to throw a pair of shoes out when they're still good. But all the shoes now come with these design optimizations. You can get them at wildfreeorganic.com/store. And I'm mentioning this today in this video because I'm about to submit the order for the shoes. So sometimes you have to wait a week or so for me to submit the order. Then it takes a week to make them and then a week to ship. So it can take some time. But I'm going to submit the order for these tomorrow or on Monday. So if you pick up a pair, they'll be put into production almost immediately after this video. So just wanted to share that with you. Let's get into our question and answer now. So if you have a question, type at Stefan Burns. I'll answer a few from the chat, and then I'll answer any questions attached to Super Thanks. And you can ask that anytime, and I will get to it. So let's get into our question and answer. And Logatha is asking, what did the Shuma resonance show last night during our collective meditation? Well, we can find out. That would be under our energy analytics portal. This is earthevolution.com/energy-analytics. And our meditation, I guess it was right about in here. We'd have to look specifically. I started the meditation, I believe, at around 8 p.m. last night. In California, it's UTC -7. This is UTC +7. So we need to go back 14 hours. And so if that is at, or rather we need to go forward 14 hours. So if we did at 8 p.m. for California, then that would be, we'd take 4 and make that, 10 p.m., then 12, so 4, then 10 hours. So it'd be 10 a.m. for Tomsk. So it'd be right about here. That is our Schumann resonance signal for Tomsk, Russia, when we did our collective meditation last night, right about there. So, and then we see this big burst happening right after that. So that's kind of interesting. Uncultured Audacity is asking, when do you think the pole shift will happen? Well, okay, there's a lot of, I've said this before, and actually, while we're on this topic, shout out to Mike and Dave because, and let me do this actually. Shout out to Mike and Dave on YouTube, their podcast, because we recently just had a chat and we talked about pole shift and everything. So I'm just going to direct you to that video, and I'll link that in the video description as soon as I finish this video. But let me show you the thumbnail for this. Oh, it's Mike and Dave Multiverse. They're a smaller channel, so I'll link you directly to them. But if we go here we see Mike and Dave's Multiverse. They're a podcast that covers a whole bunch of interesting subjects. They just posted my video here. As you can see, we talk about the sun and magnetic pole shifts was the main focus of this video. So I'll link this in the video description. You can give that a watch to answer your question. But to quickly just give you a little bit of info, there's always a pole shift, right? You have pole shifts, which is just the poles moving. You have excursions, you have reversals. So keep that in mind. Pole shift is always happening. The magnetic poles are always moving, slowly, subtly, or sometimes a lot. But that's not a technical term. Excursion and reversal are technical terms. But you can learn more by checking out that video on Mike and Dave's Multiverse. I'll link that in the video description. Definitely give that a watch. It's a really good podcast, about an hour long. One more question from the chat, and then we'll go into the questions for the super thanks. And Kathy's saying, who would have thought that the Jesus sandals would come back? Wore them in the 70s. Yeah, they're back because they're the best. They're really the best. You can hand this, I'm sure, to a pair of Aborigines in Mexico or Africa or anywhere, and I bet they would love them. I bet they'd be like, this is so great. They are honestly the best. I walked around yesterday for like 5 miles in my sandals, and it was great. And Purple Nurple is asking, what do you think will happen when the undersea axial seamount erupts? So this is a volcano off the coast of Oregon and Washington. And so I can pull up that data. This is an undersea volcano recently discovered, has had some eruptions before. It's honestly nothing to worry about, to be quite honest and frank. It's been hyped up by a lot of people. It doesn't mean it's actually anything worth fretting over. And so we'll look at it really quick. Here we have our most recent earthquakes for the 26th of July here. And so they put some seismographs out along this volcano. This outline here is for the caldera. I've talked about this before on the channel. And so it goes through these phases of increasing and decreasing earthquake activity. Here we have our caldera maps. So sometimes there's like big bursts of earthquakes here. I'm not sure we're going to find any just by kind of clicking through these. But even if it does erupt, it's not going to be anything notable. It's really not going to be anything like, oh my God, there's a tsunami now headed our way, or Oregon's going to fall off and submerge beneath the waves. These are all just online things that people say to get attention that just aren't true. It's just one of these things that people say. People just talk a lot of junk online, basically. And so that is one of these things that's now caught the attention of people, and they'll continue just saying weird stuff, and they'll do that for the end of time. It's always been that way. So here we have axial seamount here, and it's actually a little off. Here we have the seamount, and it is right at the border of the plate boundary there. And you'll see some other interesting features nearby. So there is volcanism in this area. I mean, we can see here, all these seamounts there. This is one that's very well known because it has that big caldera and extrudes effectively a pretty mafic magma. So it's not the stickiest, and it doesn't usually have these big eruptions as far as we know. But it's right in this zone. I wouldn't be worried about this. I'd be worried about Mount Rainier, honestly. Like, of all the things to focus on, the axial seamount, it's a geologic curiosity. It's a little bit of an oddity, but is it something to fret over? Not at all. Mount Rainier, on the other hand, having 1,000 earthquakes as part of a swarm, which is 10 times bigger than the earthquake swarm that it had in 2009, which was anomalous, that's something to watch. So yeah, it's like people have misplaced priorities, I feel like. But that's just my opinion, do your own research and form your own ideas. So with that, let us get into our super thanks questions and answers. So we will go here, and Pigeon Post is saying, will you reiterate to us that Yellowstone is not anything to be excited about unless it is? Thank you for keeping us informed. Yeah, I mean, Yellowstone's a huge supervolcano. Like, it's a massive supervolcano, and it could have a massive, massive eruption. So there's no downplaying the risk of Yellowstone. Like, we should all be informed as to the risk. Now, the chance of that happening in our lifetime is very, very small. But could it happen? Sure. And the ash cloud that would spread out from that would be apocalyptic, depending on the size of the eruption. It could have a massive, massive, massive eruption. VEI-8 eruptions are possible there. Is that going to happen in our lifetime? Again, we don't know. But there's a lot of people right now like making a lot of buzz and chatter about Yellowstone. And just in a couple live streams ago, we looked at the seismic data, and the stations are there. They're online. The data is coming in. So I don't know why there's all this chat about Yellowstone and the stations being offline and blah, 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 and the animals leaving when those videos are old or they're generated by AI. It's just like one of these fake news stories. So if there's actually something significant happening at Yellowstone, I will let you know. Like, I'm not here to say nothing's going to happen when things are potentially actually going to happen. There are other channels that do that. and anyone that watches my channel knows that like I'm on top of these things. Campi Flegrei, Santorini, Japan, right? We're really looking at things. But this seems to be a bit of a fake news buzz story because not everyone has the expertise to cover things in an interesting way to actually drive engagement. So they often will resort to actually making things up that seem like something apocalyptic is going to happen in order to drive engagement. Just all my own thoughts and ideas and opinions, folks, but happy to share that with you. Another question comes in from LAB asking, wondering about the effect of the electric and geomagnetic connections from sun to earth on the magma core, including the superstructures, covered effect on gas, liquid, and solids. You almost wrote that like it's a prompt for an AI. So, I'm not an artificial intelligence. But as it relates to the effect of like the sun on the earth and how deep these effects go, if you want to talk about the core and the mantle, which is what I think what you meant by magma core, then we have to talk about the magnetic field, because that is that force field that's connecting all the way from the sun down through the core of our planet and then back out. So the movement and flow of energy along those field lines is going to be important for that. Another thing that's important, and I think we're going to learn a lot more about this in the next 50 or 100 years, is neutrinos, because neutrinos have a very low interaction rate. I don't think we can pull the sun up in our Google Earth here. If we zoom around, I don't think they show the sun at all for some reason. But neutrinos are constantly being emitted from the sun, and they're passing through us every single second. They're passing through the earth. Most of them don't interact with matter at all. But there is a slight interaction possibility. And so across geologic time, there stands to reason that there is an effect from neutrino flux on the deep earth. And that fluctuations in neutrino flux is going to be one of these factors, just one of many, that influences deep geodynamics, you could say. So that's going to be another one to watch. And then as it relates to like gases, liquids, solids, I think what you really need to be thinking about as it relates to the core is plasma. Because they talk about radioactive materials that accreted down to the core and that region of the earth, and that radioactivity is helping keep the earth hot. An interesting note is that only 0.1% of the heat budget of the earth can be explained by earthquakes. The other 99.9% of the radiant heat that's coming out is from internal dynamics and like radioactive decay. But in certain zones, for example, Japan, that heat budget from earthquakes is actually closer around 10%. So it makes up a significant dynamic of the actual heat flow coming out of the earth that's being released as earthquake activity. But typically, globally, it's only like 0.1%. So we know there's this massive heat flow coming out. And the top idea for how that's being generated primarily is through the decay of radioactive elements like uranium, for example. Well, if you have natural georeactors, if you have these elements able to congregate and actually self-start a fission cycle, then you're going to produce light elements like helium. And light elements like, well, helium in particular is very stable. It's a noble gas. It has all of its electron shells filled, but it's extremely low density. So it's going to want to go from low density to high density, or it's going to want to go from high density to low density. It's going to want to leave the core and move through the mantle and then out through the crust. And we have these helium reservoirs. Specifically, there's some in the United States. So we have these flows of helium coming up. So they've formed these filamentary networks leading out from the core out to the outer edge. And what is likely the case is that some of the flow of these light elements, that slurry, is what generates the magnetic field and such. But because you have this georeactor, or at least I think that makes a lot of sense. There's a lot of evidence for that. If there is this georeactor, you're going to be producing plasma, because you're going to be releasing a ton of neutrons and you're going to have the helium and all this stuff. You're going to have plasma. So there's plasma dynamics occurring in the core. And plasma, the movement of these charged carriers, that could explain the magnetic field to a large part. You're also going to create this geodynamo dynamics. I don't think they're mutually exclusive. I think they work together. But changes to geodynamo activity could explain geomagnetic excursions and reversals, and how now the magnetic field is moving rapidly, things of this nature, because the geodynamo is maybe starting and stopping. So I hope that kind of gives you a framework to understanding some of this stuff. I mean, this question here could be like a 5-hour long lecture, right? And I don't know, I don't have all the answers. I just have a curious mind. I research into it more and more every single day. And I share that with you guys. Grushdeva, Earth grows and expands. Subduction can't be 1-to-1 if the same maximum age is shared between the continental coastlines and around the Mariana Trench. Yeah, so Grushdeva is a big fan of expanding Earth theory, and it's certainly interesting. We know that oceanic crust is being created in these mid-ocean ridges, and what some proponents of expanding Earth theory or hypothesis, whatever you want to call it, it's called a theory, they're saying that the rate of subduction does not equal the rate of oceanic crust creation. And so if you were to take that equation, roll it back in time, then that would stipulate that the Earth was once smaller and it's been actively growing. And so, I don't know, it's possible. I've been looking more and more into it. I think it's very interesting, especially if you take into account some of these factors that I discussed just with that last question in regards to the core and plasma and georeactor and more. So there could be this, if you have dense elements like uranium constantly breaking down into lighter, less dense elements, that would necessarily stipulate some sort of expansionary effect. So it's interesting. And there's our question from Brandon saying, do you play video games? If so, which ones? Thank you for your support. Very rarely play video games. I played a lot as a kid. I'm pretty good at video games, but I don't really play them too often. If I do, it's usually like some sort of like real-time strategy game, or maybe it's like Rome Total War or something like that. I like the games where I also am like learning history at the same time. But I just have too much on my plate to play video games now. But not like I don't enjoy them. I think they're a great relaxation tool, and I love Final Fantasy. I really like Final Fantasy. Actually, I should probably play some Final Fantasy, like load up a new one. Zelda's great, so yeah, those are all really good. I'm great at Mario Kart, Super Smash Bros. With the classics, of course. Thank you for the super thanks, Jason. And Pigeon Post, if the predictions about California were true, I'm correct to assume you wouldn't live there. Well, I mean, a lot of people, it's another one of these like internet things where some people think California is going to like fall off the coast, and they're always making these proclamations. It's going to happen next week. It's going to happen next month, and then it doesn't happen. They just keep pushing back their date. Again, California is not even the most seismically active area. Like Mexico is more seismically active than California. Japan's way more seismically active than California. Hawaii is not more seismically active, but it's surprisingly seismically active. So California is just, I think there's like this politics that gets wrapped up into it because the politics of California is totally nutso. And so because of that, people want California to have a big earthquake and some reset, and the sinners will like, slump beneath the waves. Like you get all these crazy things on the internet, and it starts to drive these discussions away from just like the fact of the matter. So, I mean, if by living in California, am I taking on some risk about an earthquake? Yeah, but by living over here, I'm taking on the risk of tornadoes. And if I live over here, I'm taking on the risk of hurricanes. So it doesn't matter where you live, there's always going to be some sort of risk. That's basically unavoidable. We have super thanks from Dana. Thank you so much. Also one from Jason again. And we will have a small G1 storm from the coronal mass ejection blast a couple of days ago. Yeah, let's check out that model really quick. We've been looking at that on the channel, but in today's live stream, we haven't looked at our real-time solar wind, or rather our solar wind prediction model. So you can check it out. They expect it to come in around 8 a.m. Universal Time, so in less than 24 hours. And so we'll see what happens. Here we see that solar storm. It's actually 3 of them combined, according to Tamitha Scove. We see it launched there. This is top-down view. This is south-north view. So right smack dab on the ecliptic, boom, there's our plasma density hit at 8 a.m. Again, this is a model not reflective 100% of reality, but they're generally pretty good. Sometimes they're really off. Sometimes they're spot on. That's how life is. They're generally pretty good. That was a surefire shot towards us. We have a coronal mass ejection impact coming in less than 24 hours. So again, that's why these earthing shoe products are so valuable. If you are energy sensitive and you don't want to be barefoot, or it's not feasible or really the best thing to do, right? Let's say it's a lawn where a whole bunch of dogs are, you know, relieving themselves. You probably want to have some shoes on, but you still want to be connected. That's all available on the website, wildfreeorganic.com/store. And then the last one we'll take is from ROTN Dog here. Anything new on the SMOC reversal? No, not anything new on that. Just saying reversal is a little bit of a simplification. It was a change in the salinity characteristics at the surface. So we had a very low salinity regime going up to about 2016, and then it switched to a high salinity regime. So is that indicating that the circulation is changed like completely? Like there's definitely some changes in circulation because of now there being more saline water at the surface rather than at depth. But can we stipulate that, for example, the circulation of the entire ocean around Antarctica has changed, right? Can we say that the ocean circulation of this entire zone has changed just because there's been, you know, salinity changes for the past 10 years? No, I think that's a stretch. This again is this salinity shift just occurred in the past. It occurred in 2016 or so, like 2014 to 2016, and we don't have that long of a time frame for these measurements. This is satellite measurements. So if we had 1,000 years of data, we can know what the periodicity of these salinity changes is. But we don't have that data. It's fairly new. So is this a once in 1,000 year salinity shift, or is it once every 15 years or something like that? That's data that we just don't really have. So we can't look into that too much, though there are going to be some climatic effects from that, certainly. One of the climate effects from a change in the salinity, according to that paper that came out, because I read the paper, it wasn't that long of a paper, was that you're going to see drier conditions in the Mediterranean, and you're going to see like drought-like conditions in the in the Caribbean, not the Mediterranean, in the Caribbean. That's one thing that they talked about there. So if we see that, then that's good evidence supporting some of these claims that were put out by those authors on the SMOC. So that is it for today's video. Thank you all so much for watching. Wishing all of you well. Again, I've been your host, Stefan Burns. And that's what we discuss on the channel. All these things and more: geology, geophysics, space weather, solar activity, cosmic forces, and more spirituality. We did an amazing live stream meditation last night. Go check that out if you haven't already. And also go check out the podcast I did with Mike and Dave on Mike and Dave's Multiverse, as linked in the video description below. These shoes, the earthing shoe products, are all available at wildfreeorganic.com/store. And please smash the like button, help the channel grow. Subscribe. We're on the road to 500K. We just hit 365,000, which is awesome. So thank you all for the amazing community that has coalesced around this channel. I'll keep doing everything I can to keep you informed and in the know as to what is happening with the Earth. So please subscribe if you'd like to stay up to date. I look at things from all different perspectives, but I do my best to also cut to the truth and not entertain, clearly false narratives and things of that nature. I'm just one human being, so I do my best to cover everything. I'm also not God, so I do my best to stick to the truth as close as possible, but please do your own research and more. That is my closing message for you. Again, wishing all of you well. Please take care of yourselves, and I'll see you all in the next video.